The definition of an nth root is basically what number times itself that many times to give me a particular number. So if b is an nth root of a, okay, then you'll have b to the n equals a. So we want to look at the example 2 to the 4th power. 2 to the 4th power is going to equal 16. Why? Because 2 is the 4th root of 16, which means that you have 2 times 2 times 2. So essentially you have a number multiplied itself 4 times, and that would be the 4th root. So the root is basically telling you how many times you take that base and multiply itself to get a product. So 2 is going to be the base in this case, and then 4 is our exponent or root. So 2 to the 4th power, 2 times 2 times 2 times 2, will in fact give me 16. Okay, and that's your final product when you multiply those 4 exact numbers together. Notice that they're identical. It's a number times itself an X amount of times. In this case, it's 4 times. So if you look over here, all right, n is the index or the root, and a is going to be some number. We'll call that, a, and that is the radicand. So, for example, you look at this here. What is asked is you're taking the cubed root of 64. So 3 is going to be your n. And a, in this case, is going to be 64. Okay? And this problem is asking you to take the cube root of 64. Well, keep in mind that you're going to have 4 times 4 times 4. Okay? 4 times 4 is 16, times 4 is 64. So the cube root of this number is going to be 4. As long as it's multiplied itself 3 times. The root is going to tell you how many times this base is going to be multiplied, this number, this radicand. This radicand in this case is going to be 64. So we got to think, okay, what times what times what will give me that 64 right back? The only number that's going to work is going to be 4. If you check with your calculator, do 4 times 4 gives you 16, times 4 is 64. So the answer is 4. Okay? We can look at another example, okay? And we're going to take the 5th root of negative 32. Okay? Now keep in mind that the index is going to be 5, okay? And that's, we're taking the 5th root of 32, but it's not positive, it's negative. So the answer for this is going to be, again, n in this case is going to be 5, and then a, which is your radicand, is going to be negative 32. Well, remember that the only number that times itself 5 times to even give me a 32 would have to be 2. Okay? So it's basically going to be not only a positive, but it's negative, because if I take negative 2 and I times itself 5 times, okay, 2 times 2 times 2 times 2 times 2 will in fact give me 32, but if you have an odd number of negatives, you should get a negative number. So technically, negative 2 multiplied itself 5 times will in fact give me a negative 32, an answer of negative 32. Again, this works because the root is odd, and if you take the odd root of any negative number, you will get a negative answer. Okay, you just have to figure out what number is being multiplied itself that many times, but the sign will be negative. If the root is even, then your answer will always be positive. So you got to really look at the number under the radical. Okay, if it's negative and you have a odd root, your answer is negative. If the number under the radical is positive, okay, and you're going to get a positive answer. Now, if the number under the radical is positive and you have an odd, an odd root, just keep in mind that an even root and you have a number under the radical that's negative, you can't do that because every time you multiply two pairs of negatives, you're always going to get a positive. So, for example, a good example would be this, okay? Here, I'll do this one here. So let's do an example of what happens when you have an even root, but then you have a negative radicand. Okay, so this goes back to what I was saying a moment ago. Yes, I can find the number multiplied itself 4 times. I'm taking the fourth root, so 2 times 2 times 2 times 2 would give me 16, but keep in mind that if I do negative 2 times negative 2 times negative 2 times negative 2 4 times, I don't get negative 16. I get positive 16. Well, I want to get negative 16 because I want to take the fourth root of a negative 16. So I can't do this. If you do this on a calculator, you're going to get an error message. So that's because the root is even and you're taking the even root of a negative number. So you're always going to get not a real number. Okay? So the answer is not a real number. All right, so that's really important to keep in mind. As you got, the sign really matters in this case. Okay. Let's look at another example. Okay. Again, what if I do the fourth root of 81? Can I do this? The fourth root of 81. Again, we got to think of a number times itself 4 times, okay? So if you look at it, if you do this on the calculator, you're going to see that it's actually 3, okay? Because I'm going to have 3 times 3 times 3 times 3, and that will in fact give you 81, right? Okay, so a number 3 times itself 4 times will give you 81. So the fourth root of 81, you're just simply going to say it's 3. This just shows you how many times you got to multiply that radicand, which is 4 times. Remember, the root tells you how many times you're multiplying that radicand by itself. Okay, so 3 would be the answer for that. And you notice that the number in the radicand is positive, so I should get a positive answer always. Okay. Let's do one more. Let's take the 6th root of 1 million. Okay. 6th root of 1 million is going to be actually 10. because 10 multiplied itself 6 times. That's the answer. Why? Because ten times itself 6 times will in fact give you the million right back. Okay? And if you verify that on the calculator, you're going to see that it's 10. And it's a positive 10 because the answer in the Radican was originally positive, so you should always get a positive result. Okay? That is how you do, how you simplify nth roots. Okay? Now, there are other examples I want to show you, okay? And we're going to do that in the next lesson. And that's going to be on the next page. Okay, so we're going to be simplifying. Whoops, let me go ahead and use my color scheme here. So we are going to be simplifying expressions of the form nth root a to the nth power. This is the form we're going to work with. So let me just give you an example. We'll try to break this as easy as I can. We're going to take the fourth root of negative 3 to the fourth power. Okay? And the easy way that I can explain this is that if you take negative 3 and you raise that to the fourth power, okay, and then take the fourth root of that, you're going to get your final answer, okay? So you can use a calculator to verify it, but you can also think of the absolute value, okay? So if you take 3, okay, and you raise that to the fourth power, okay, you will in fact get 81, okay? So, and then if you take 81 and take the fourth root of that, you should get 3, because 3 times 3 is 9, times 3 is 27, times 3 is 81, okay? So you can simplify the exponent under the radical and then take the fourth root of it, okay? That is generally one way you can do it. There are several other ways you can do this, but for now, just to understand the basic concept, I'm just going to explain it as simplifying the exponent and then taking the nth root of it, okay? And that way you will get your answer. Let's look at another one, okay? Let's look at, how about the fifth root of negative 3 to the fifth power, okay? If you take, now keep in mind, if you take negative 3 and raise that to the fourth, that's essentially saying negative 3 times itself 4 times, and you have 4 negatives, that gives me a positive. And that's why it's positive 81. Then I took the fourth root, which is basically a number times itself 4 times to give me 81, which we realized was 3. This next second example, we're going to take 3 and we're going to raise that to the fifth power, okay? So if you take 3 and then raise that to the fifth power, okay, you get 243, and then you take the fifth root of that, and then you will also get 3, negative 3, okay? So Okay, so if you take negative 3 to the 5th power, that's going to give you negative 243. And then if you take the 5th root of negative 243, you should get minus 3. Because you're taking the 5th root, which is odd, and that radicand is negative, so your answer is going to be negative. Again, you can use a calculator to simplify larger numbers as long as you get the concept of what you're doing. That's really all that matters, is that you know the math behind it and why, what it is that you're doing exactly. Okay, so we can do another example. Let's say you had the square root of x plus 2 squared. Okay. Well, if you have a polynomial and you're squaring it and then you're taking the radical of that, that's essentially squaring it. So you're just going to get whatever's in the parentheses. This is just going to be x plus 2. You don't necessarily need to FOIL x plus 2 and then take the square root. You could bypass all that by just simply telling me what's basically under the radical in the parentheses. Okay, it's a little bit of a shortcut. And another example that you can do is, let's say you had the cube root of a plus b, and then you're trying to cube it. Again, if you take a plus b and times itself 3 times, that's a little bit of a process, right? Because you're dealing with polynomials, and then you take the cube root, you get your answer. But the fastest way to do it is just tell me that it's a plus b. It's whatever's in the parentheses. Because if you're cubing a radicand and you're taking the exact nth root of that, okay, you notice that 3 and 3, you notice that the root 3 and the exponent is 3, it's identical, okay? For this example, it was automatically a 2. We just don't write 2 as a root when you're taking the square root. It's understood that you're taking the square root. You only write the root if it's larger than 2, okay? So here, if the root and the exponent are identical, you just write what's in the parentheses to save you a lot of work, okay? Another example here, if you look at the square root of y to the 4th, okay? Again, this equals y squared times y squared, okay? Because if you multiply the same base, you add the exponents. You add these up, okay? So essentially, y squared times y squared, that is the reason why it's y4, because you're adding 2 plus 2, which is 4. So the answer to this is just y squared, okay? And that concludes these examples.